Hello everyone, this is Casey with Foundation Testing and Consulting. We've developed a database connected to online dashboards for visualizing various correlations with previous PDA test results from various bridge projects. We initiated this database and dashboards with our own data sets for projects in Missouri and Kansas, hundreds of projects, and then KDOT supported the effort by subscribing to what we initially furnished from our data sets, but they also supplemented it with their own data sets. So what I want to show you is this application we call PileTrac that was developed by FTC. We have a patent pending on it. It's a really novel approach to take what would normally be just file fodder and turn it into useful information. Not merely data, but information you can use to plan your bridge project construction, and also early on in your design you can vet various pile types, see what's been done historically. One of the important reasons we decided to do this is to essentially preserve the institutional knowledge that an organization has gained about what types of piles work best under different circumstances, along with the associated hammers, and capture information about where things didn't go according to plan so that you could avoid having a similar occurrence on future projects. So that was really the driver behind this. Kansas DOT has been using this for about a year already. At the time of this recording, this is July 2023. So again, I appreciate KDOT support. The reason I want to show you these examples, keep in mind, this is from our data sets in Missouri and Kansas. If we're working with DOTs, if you elect to have us take your historical project information and enter it into the database portion that you subscribe to, we can have very granular permissions such that you won't be seeing other people's furnished data, and they won't be seeing your furnished data. So if we do this for another state, you could provide us with the data sets. If you subscribe to the service, we'll populate the database and dashboards, and it's very useful. So please keep in mind, these are just example data plots to give you an idea of what can be done with the data. We expect that each individual DOT will have their own specific needs, their own unique pile types and challenges. So it's a process of discovery. With data analytics, you want to look at what's happened in the past, understand why it's happened, and going forward predict outcomes. So it's a very powerful set of tools. So in the next few minutes, I'll show you specific examples from our data sets in Missouri and Kansas. Again, this is just to give you an idea of what can be done. And you can see here average pile length per supported kip by pile section type. The Missouri data set includes some very large capacity pipe pile up to 4 feet in diameter. We have required capacity by pile section name, which is an average. You can hover over and get more information. So this 4-foot diameter pipe pile job in Missouri, you can see that required capacity was 2,700 kips and the average was 3,500. And then we go over here to pile depth by pile section name, which is the average pile depth. Again, Kansas and Missouri, we could just toggle to Kansas only if we'd like. Plot will refresh. I like this a lot, and I think this plot is going to be extremely useful to people in your construction teams who are evaluating selection of various hammers proposed by the contractor, or even want to get an idea of what the performance is likely to be relative to stroke and pile set for a given capacity and a given pile length. So for example, I just recently tested some pile at the Amidon project in Sedgwick County, Kansas, the City of Wichita project, and that had a D1632 hammer. So I'm going to deselect all and just select the 1632. And for the pile section name, go down here to 12 by 53. And we can see that this gray band is within a half a standard deviation of the average. And you can hover over these values as well. But that gives you an idea of what the typical depths are, roughly 45 to 55 feet long for a D1632 hammer. Let's say I wanted to get an idea of what the pile set would be for a D1632 hammer, and I'm going to drive HP 12 by 53, so I'm going to deselect all, and I'm going to go down to 12 by 53. And I've got a best fit line here, and I could look at the slope. I could figure out what the pile set should be roughly for a given pile capacity. So for Amidon, we just tested, had a required capacity of 268 kips. So per this chart, we'd have a pile set of 0.26 inches per blow. And in a similar fashion, let's look at stroke. Just go with the D16, which is the hammer we used at Amidon, and the 12 by 53. And for 268 kips, we would have predicted a 7.9 foot stroke. So in actuality, we had a 0.28 inch per blow set versus the 0.26 predicted, and we had an 8 foot stroke versus the 7.9 feet predicted. So these charts are working out better than I would have hoped. We created them just to get a rough idea of likely hammer ram stroke and pile set. The few jobs I've done since we've populated the data sets here into PileTrac, it's tracking very well along the best fit line. So again, you can look at different hammer selections and different pile sections to kind of get a rough idea of what you would expect it to drive out to. I guess conversely, you could look at the set and stroke and for what you had in a situation and get a rough computation of what the capacity would be. Average penetration into bedrock by county. So if you hover over, here's Sedgwick. The range among the data sets is 3 feet to 43 feet. Average was 17 feet of penetration. So I think this is a pretty useful plot to get an idea of roughly what kind of penetrations you're going to look for. Average actual pile length by county. So let's look at Sedgwick, 53 feet. Average capacity by county. Let's see what the average is for a 12 by 53 in Sedgwick County. 330 kips is the average total tested capacity for a 12 by 53. I'm really happy with this one right now. Total pile capacity versus log time. These are all Missouri data sets at this point because this is hand curated data. I was interested in capacity increases over time for either H-pile or pipe pile. So let's just look at one county just to give you an idea. Required capacity was close to 300 kips on this job. So at this depth, we were well short of capacity. And so these were extended driving depths. But what's interesting is the overall slope is very similar. So if you have a pretty good handle on what your initial capacity is, and after one or more log cycles, which would be less than a week, you could calculate what your capacity would be after that waiting period. It's an opportunity to get an idea of, perhaps you could set a lower initial target capacity and confirm that you have it by PDA, and with a large enough data set, get to a high degree of confidence that what the future capacity is likely to be after a certain waiting period. Then we have pile depth versus bedrock depth, average pile length versus plan length with our best fit line. If you have an interest in compiling your own state's PDA records into this PileTrac application that you could then use on a subscription basis, my contact information is listed in the description for this video, so please reach out. So hopefully this gives you a pretty good idea of what's out there, what's possible, and it was the first time that type of piling had ever been used in certain conditions. So again, thanks for watching. Please reach out to me through my contact information listed in the description, and please stay tuned for future videos on this channel. I'll be providing additional information as we go forward. Thank you very much.